Resistance of the sample increases linearly from minus 180 degrees to about 15 degrees Celsius, where it peaks. Subsequently, the resistance decreases non-linearly with further increase in temperature. If R is inversely proportional to theta, then the product R theta should always be equal to a fixed constant, say K. So consider the 2 points given here. So when theta is 80, then the K will be 96,000. However, when theta is 100, K is 80,000. So the two values are not the same. Hence, the proposed relationship is not correct. The value of R is 160 degrees is read off from the graph. 1 over T and ln R is calculated from theta and R. So these are the two equations. When graph of ln R against 1 over T is plotted as in figure 7.3, the data points seem to follow a linear trend. This suggests that the equation is correct. From the baseline fit, these are the two values. EG will be 0.235 electron volts and A is 8.26 times 10 to the power minus 3. N-type semiconductors have much lower resistance compared to intrinsic semiconductor. In N-type semiconductors, the presence of group 5 dopant atoms introduces few electron states just below the conduction band of silicon. At room temperature, almost all of these electrons will possess sufficient energy to be excited into the conduction band of silicon and hence able to contribute to conduction. In intrinsic semiconductor, the band gap between valence and conduction band is much larger than that between the group 5 states as mentioned earlier. Hence, the number of electrons that possess sufficient energy to be promoted from valence band to conduction band is much fewer than above. Hence, there are much fewer mobile charge carriers to conduct electricity. Resistance increases with increasing temperature for metals, whereas it decreases with increasing temperatures in semiconductors. In semiconductors, the concentration of mobile charge carriers increases with temperature, whereas the concentration of mobile charge carriers stays constant for metals. Moreover, at higher temperatures, the more vigorous lattice vibration creates more obstruction to the flow of electrons.